Hey, it's welcome. Yeah, so one reason why this integral is interesting is because we're doing trig sub, but the integral itself involves trigonometric functions. But it turns out that here, a substitution like u equals tan theta will go a long way, and you'll see why. Now, this lower limit then would have to become, and let's call it u1, it would have to become tan of 0, and that's equal to 0. And then this upper limit will become, let's call it u2. Then that'd be tan of pi over 4, and that is equal to 1, right? And so our integral then could be rewritten as the integral from, and that's probably not big enough. Okay, that's big enough. From 0 to 1, you'll see why I drew a big integral. And now we need a replacement in terms of u for d theta, cosine squared theta, and then sine squared theta. Once we rename these guys in terms of u, then we'll have our entire integral be about u. Yeah? Not you, like you. Okay. Anyway, how do we get to d theta? Well, based on this substitution that u be equal to tan theta, it's clear that du is equal to secant squared theta d theta, wherein we realize that d theta is equal to du divided by secant squared. Now, remember, u is tan theta. U is tan theta, and therefore u squared plus 1, which is tan squared plus 1, is equal to secant squared theta. So it turns out that d theta is equal to du divided by almost right on. Du divided by 1 plus u squared, which is u squared plus 1. Okay? Yeah. Okay, cool. So we've got d theta. Now, what about cosine squared? Well, since secant squared is equal to 1 over cosine squared, it's clear then that cosine squared is equal to 1 over secant squared. And so that is 1 over, or 1 divided by, and that is 1 plus u squared, or u squared plus 1, but I'll write 1 plus u squared. Okay, cool. Now, what about sine squared theta? Now, again, u is equal to tan theta, and so then u squared is tan squared, but tan squared is sine squared divided by cosine squared. Divided by cosine squared. So if I multiply this equation here on both sides by cosine squared, I can get sine squared by itself. So sine squared is u squared times cosine squared. But wait, cosine squared from here is 1 over 1 plus u squared. So instead of cosine squared, I can write u squared here times, instead of cosine squared, 1 divided by 1 plus u squared. But why would I do that when I could just make a denominator here, wherein in the denominator we write 1 plus u squared. Yeah, so we've got sine squared figured out, cosine squared figured out, and then d theta figured out, all in terms of u. And so we could rewrite this whole integral entirely in terms of u. And on the numerator is going to go something we already wrote down, which is d theta. So let's save some time. So, this tool is not cooperating though. Come on, man. Okay. What about now? Oh, no, I didn't say rotate. I said move it. Move it. Okay. That's better. And then shrink. Okay, cool. See? Like on command. What? No. And then divided by and 3 times cosine squared. So that's 3 times this guy. And so that's just 3 divided by 1 plus u squared. Okay. Let's do this quickly. And then plus sine squared, which is u squared divided by 1 plus u squared. But notice here I could just add them together and write 3 plus u squared divided by 1 plus u squared. So I prefer to write that. So 3 plus u squared, and this divided by 1 plus u squared. Okay, it's pretty clear what we're going to do next, but you know, that's beyond predictable. Like, yeah, delete this first. Alright, what we're going to do next is clearly this. Boom, boom, right? And then next is integral from 0 to 1 of du divided by 3 plus u squared. Now, if you need help on figuring out what this integral has to be, then a good start is like to write a third, and then to write, like, I'm going to abandon the limits for a second because I'm just showing you how to work out the integral. And so a third, and then du, clearly this 3 here came out of the denominator by factoring it out of these two terms. And so then I have to write 1, and then plus, and then it's going to be u over root 3 squared. And then here you can make regular substitution, I suppose, with something like t equals u over root 3, and go from there and clearly recognize you've got tan inverse of u over root 3 as part of your solution. But yeah, you could finish that. I'll just tell you the result. So the integral of du over 3 plus u squared is going to work out to be root 3 divided by 3, and then tan inverse of u over root 3. At least this part you should know from what I just showed you. But yeah, okay, cool. And of course, this is evaluate from what is it? From 0 to 1? Okay, cool. So that's all we have left to do. First, we'll have root 3 divided by 3, and then tan inverse of 1 over root 3. Well, what's that? Tan inverse of 1 over root 3. So we're definitely working with a 30, 60, 90 degree triangle, and we want the opposite side to be 1, the adjacent side to be root 3. So we got to be talking about 30 degrees, which in radians is pi over 6. So instead of tan inverse of 1 over root 3, I'll write pi over 6. So I have root 3 over 3 times pi over 6. And then we have minus root 3 over 3 times tan inverse of 0 over root 3, which is same as tan inverse of 0. So I have tan inverse of 0 being 0, root 3 over 3 times 0, but why bother write this? This whole thing is 0, right? And so I'll backtrack, no, not that way, this way, and say that our final answer is, what? Sorry, I saw a stain. Our final answer is pi times root 3 all over 18. And that is it. Yeah? Alright, cool. I hope you enjoyed this and keep watching. Take care.